in there, and it turns out that it was John Brown that put it there. He said it was gold iridium wire, but we analyzed it with our energy dispersive system. It turns out that that was pure nickel, and so we went ahead and looked at that in different ways. When we got ready to do the FTIR, we completed the FTIR studies. Then we said, let's go to the X-ray fluorescence studies. And you can see that by mapping, they can get the calcium. So there was calcium all through the thread. There was iron all through the thread. This was the R1 sample. There's potassium all through the thread, and there was phosphorus all through the thread. Now, why? We don't know, but there was silicon all through the thread, and there was sulfur all through the thread. So those are all things that are within the thread, and they looked at this. This is a spectra of all the X-rays given off when they used a rhodium X-ray excitation source, and it's pretty obvious that there's minor amounts, but we did not see any aluminum. Silicon, yes. Phosphorus, yes. Sulfur, yes. Potassium was a strong signal. Iron, yes. And with sodium, it's too low for an X-ray fluorescence instrument, but we could see the sodium with other things, and it's definitely there. This is a relative composition, and you can see that of the elements that we looked at, calcium and potassium were by far the greatest composition. In the composite, in the multi-fiber thread, it's still the greatest. There was a silicon hotspot that they focused the spot on, and it gave, of course it's going to give a lot of silicon. It was about 4.7%. The iron hotspot that they found, they looked at it, and it had 2.5% iron, but the calcium and the potassium and the iron were the primary things that there was. And there was surprisingly a large number of sulfur in there. Okay, discussion. The goal of all these analyses was to analytically determine the identity of the cloth on the rays and carbon-14 sampling corner by analysis of 3 threads taken from that area. The approach was to determine the identification of each of 3 sample threads by analytical methods and to confirm the identification by comparison to cotton and flax standards. The objectives were to establish a list of analytical instrumentation that is appropriate and available for conducting the study. That was our first objective. To determine the relative effectiveness of analytical methods for material identification of 3 threads. To conduct the studies non-destructively and without contaminating the samples. Given the main original shroud cloth is linen or flax, we received and analyzed 3 threads, 8 to 12 millimeters in length and about 0.2 of a milligram in mass. The limitations and assumptions for our work, we did not have an actual shroud linen standard. This is a rather critical thing. Just last week, I told them to go ahead and take the sticky tape sample, and according to directions from Joan Rogers, she gave me a procedure for cleaning away the material, the glue from the sticky tape sample, so that we could actually take and look at individual fibers with our FTIR instrument. The 3 thread samples analyzed are representative of rays in carbon-14 sample areas. it would have, that's a limitation and an assumption also. The conclusions, all the conclusions from this study are from actual analytical data of 3 samples taken from the rays, 1973 and carbon-14, 1988, sampling corner, lower left corner of frontal image area of the shroud. The many strands of fibers from the 3 threads analyzed gave FTIR signature spectra of cotton and definitely did not give evidence of linen flax fibers. In the first analysis we did, we saw maybe some impurities of flax there, but we went back and they looked at those over and over again and they said, no, this is just cotton. That's all there is to it. The FTIR data confirms the Ray Rogers assertions that he made in the thermochemical acta that the material from the radiocarbon area of the shroud is significantly different from that of the main cloth. It confirmed that. The radiocarbon samples was thus not part of the original cloth and is invalid for determining the age of the shroud. That was his 2 main allegations in thermochemical acta. The samples taken for the carbon-14 dating of the shroud in 1988 were all taken from the same corner and were not representative of the main shroud. What was true for the part was not true for the whole. And that's one of the basic rules in doing analytical chemistry, is that if you have a sample that you're going to analyze, that sample must be representative of the whole. Especially if this sample is to characterize an area or a population. Here again, the sample must be representative of the whole. And they did not do this. Therefore, the approach used for conducting the age sampling, age dating, was flawed, and the results are therefore invalid. The recommendation, a new age dating must be conducted on samples that are representative of the shroud image area. This is an acknowledgement for the people that worked on this. This is all, they're all Los Alamos people. They're all PhDs and very knowledgeable in their area. And that's it.